The title of this paper is The Effect of Injection Molding Parameter on Fill Time Using Moldflow Simulation Software. Introduction. We can see that injection molding, the most important is the quality of the product, which depend on the material, design of the mold, and process parameter. We can see on the right side how the quality is very important when these three items combine together for injection molding. Incorrect parameter settings such as cycle time, melt temperature, mold temperature, cooling temperature, and rate of injection can all causes incorrect production part to be created in terms of differing component of weight, incomplete short, and overfilling. You can see on the right figure where there's temperature versus the pressure. If the temperature higher and pressure is higher, then it can fill the short. If the higher temperature and lower pressure, the thermodegradation will happen. If the temperature increase and pressure increase, okay, the flashing will happen. That is how the relationship between parameter. However, by simulation flow analysis process, it has capability to determine potential part defects such as wear line, air trap, and sink mark. We can see that on the right side figure where using the simulation software, we can predict the flow of melting plastic filling the mold cavity uniformly and finally achieve high quality manufacturing as a real world processing. In order to achieve the optimization of injection molding parameter, a systematic method is needed to determine the relationship between process factor and the output of the responses. One of these is by using Taguchi method. Okay, we can see that's on the figure where Taguchi is one of the robust design. When the control factor in the process, the input can be predict the outputs. That means the input of the product material, for example, then the control factor can be get the output by using some sophisticated method. The objective of this project is to find the most significant parameters such as melting temperature, mold temperature, injection time, and the number of gates that affected responses, which are fill time using moldflow simulation software. Second, to determine the optimum level of parameter using Taguchi method, and last is to improve the responses using optimal level parameter. This flowchart shows the methodology of this project. We can see that first is starting with development of design the parts, then transfer the design to a Autodesk Moldflow Advisor using MPA software. From the simulation, analyze the data based on most significant parameters that affected the responses. And last is make validation from the result by using the design experiment Taguchi and ANOVA. This table shows the process parameter, where is the melting temperature, mold temperature, 6 injection time, and number of gates. And then figure 1 show the different color of indicator that show the start and the final of the fill time measurement. From the figure, it shows that the highest fill time is 4.284 seconds for the fill time. Objective number 1. We have to find the most significant parameter. By using the analysis of variance for fill time, it shows that injection time has the 90% contribution. Table 3 shows the analysis of variance all over of fill time where the injection time dominant the contribution. This result has shown that the influence of the fill time as input parameter to the fill time of the reservoir always parallel to the relationship. Objective 2. The most optimal level by using the SN ratio. The table of the left side shows that run number 7 has the highest fill time, 4.284. Meanwhile, for run number 1 and number 8 is the lowest fill time, 0.2059 seconds. SN ratio graph shows only injection time has the higher distance and the most significant to the fill time. We can see that on the graph, the melt temperature 320 degrees Celsius, mold temperature 120 degrees Celsius, injection time 0.2 seconds, and the number of gates is 1. The highest value for the SN ratio for injection time is 0.2 seconds. Meanwhile, melt temperature is 320 degrees Celsius, mold temperature is 120 degrees Celsius, and gate is number 1. However, from the graph, it shows that melt temperature, mold temperature, and gate are not significantly factor to the fill time because the graph show the horizontal pattern as compared to the injection time show the very significantly different. Objective number 3 is to improvement fill time by taking the lowest the better of fill time. From the gradient equation, we find that the fill time reduced to 0.1844 seconds, which reduced the fill time 11.66%. Conclusion. It can be concluded that injection time is the most significant factor affected the fill time, followed by number of gate, mold temperature, and melt temperature. Injection time contribute 99.99% out of 4 factors selected. The level of optimum parameter are injection time 0.2 second, melt temperature 320 degrees Celsius, mold temperature 120 degrees Celsius, and at gate number 1. After optimization, predicted value reduced 0.1844 second as compared to the 0.2059 second from actual value, which decreased the fill time to 11.66%. Thus, if slight change of injection time, it can affect the fill time immediately. Thank you very much.